Hey everyone, so today in this video we're going to be covering deep Q networks, or DQN. So what exactly is it? Deep Q networks, or DQN, is a reinforcement learning method that predicts Q values for actions using a neural network trained on past experiences. So the agent explores and interacts with the environment, it collects experiences, and calculates rewards. These experiences are then stored and used to train a neural network, which will improve decision making over time. So the differences from Q learning to DQN is that Q learning uses a Q table to store and save all possible states with their estimated rewards, while DQN instead uses a neural network to just find patterns to predict Q values for a specific state based on past experience it was trained on. So again, the big difference, Q table stores all the possible states. DQN doesn't know all the possible states. It just moves around in the world and figures out patterns to what will give a positive reward and what will give a negative reward. So some fundamental keywords we need to learn are the Q network, which is just a neural network that predicts Q values for state action pairs, and a replay buffer, which is just basically a list that stores past experiences and will later randomly sample them for training. So how does a DQN work? So instead of a Q table, it uses a neural network to again predict Q values for actions. So the process is that the input to the neural network is the current state, so the vision of the environment or the agent, and the output is the expected Q value or reward for each possible action. So for example, like move left, the Q value might be -1. For up, the Q value might be 1. For right, it might be +2. So then the agent selects the action with the highest Q value, and after that move is made, it then calculates the true reward because that was the predicted award, but what was the true award after that move is made? And it will basically save that to the save the experience to the replay buffer. So for an example, imagine this is the environment that the agent is in. Now, step 1, the agent observes the environment. So let's say this is what the agent currently sees in the world. And since its vision is limited, in DQN, it doesn't save the whole world. It doesn't save every possible state. It just gets a snippet of the world, its surrounding world. So this could be, for example, its X position, its Y position, and the X position and Y position of the nearest coin, and then maybe some data on obstacles. Next, it has to choose a random action. Since the agent has completely no knowledge of the world, has no idea if moving to the right will give it a reward, if moving to the left will give it a reward, it has no idea what these obstacles are, has no idea what this coin is, it doesn't know anything. So it needs to just take random actions to start learning what gives rewards, what obstacles are, what a coin is, etc. So we start off choosing random action. Let's say it moves right. So it would execute that action and calculate the true reward. So since the agent got closer to the coin, let's say it gets a +1 reward. So since the agent got a +1 reward and made an action, it needs to save that experience to the replay buffer, which is, remember, the list of experiences. So save it in a format like this, where it's the original state, the action it took, the reward it got for that action, and then the results state, so the resulting world. So again, here is the previous state, here's the action, it took a right, it got a +1 reward, and the resulting state is him in this new area, seeing this world. So now we basically just repeat new actions until the replay buffer is almost full. And the agent, as you can see, will just start making a bunch of actions just randomly and figure out what gives negative rewards and what gives a positive rewards. So once the replay buffer is full, and remember the replay buffer will have like probably thousands of entries that we will train on. So imagine just hundreds of these. And we will train the network using all like a batch of these. So example, if the agent sees moving away from the coin gives a negative reward, it will learn to not make these actions in the future and will learn to make actions similar to this. And so note, the network will find patterns on its own based on the state it moves to. So for example, in state one, let's say its XY position is further away from the coin. And in S2, the XY position is closer to the coin. The network will find, since it got a +1 reward and it moved right from this state, it knows that moving right got it closer to the coin, and it will try to do that in the future. It will learn how to do that on its own. So after using the experiences to train the network, we'll call that the end of one training episode. And we'll repeat the process and slowly let the agent decide the best actions to take. So at the end of this process, we basically hope that the agent or the neural network will learn what actions give the highest rewards from a given state. So for example, if we like pass in x, the x position of the agent, the y position of the agent, the x position of the coin, and the y position of the coin, then we'll hope that it will output the best action to take. So maybe right, it has the highest rewards. We'll hope it outputs that. Now the limitations of DQN is that it's very slow. It requires thousands of games, iterations, and it needs a bunch of movements in the world to learn like a policy. It needs to learn something that provides the best rewards. So there may also be overestimation bias where Q values or the predictive rewards may become inaccurate. So like the agent might accidentally think moving away from the coin actually provides higher rewards in the future. So the next limitation is random action versus best action. It's hard to balance when it should learn new things and take random actions or when it should just use its learned neural network. So like I said, it's hard to decide when the agent should choose a random action or when it should just use its final outcome neural network and just trust this, rely on this. Because we can't just let the agent keep doing random actions because it will never be able to like play the game good because it won't be using the neural network. So overall, the DQN recap is that the DQN is an improvement over Q learning using neural networks instead of Q tables. It uses replay buffer to save experiences, and it's trained using rewards from experiences to maximize the long-term reward gains. So next video, we'll set up the Godot environment to help us start creating this DQN agent.